Good afternoon to all. Good afternoon to all. Good afternoon to all. Good afternoon to all. హలో చెప్పండి మ్యామ్ చెప్పండి. ఓకే 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 మీరు నేమ్ టైప్ చేసింది ఆ ఫోన్ నుంచే ఇద్దరు నేమ్ టైప్ చేయండి. గుడ్ ఆఫ్టర్నూన్. ఓకే గుడ్ ఆఫ్టర్నూన్ టు ఆల్. Okay, I will start my class. So basic electrical circuits. Let us first of all I will start with resistor. So I have the basic electrical circuit elements are resistor, inductor and capacitor. So you can see that in this image. Okay then, so these are the resistors. So these resistors we can see there are color coding provided to these resistors. So depending on the color coding that has been provided, the value of the resistance will vary. If we know the each color coding value, we can calculate the resistance of each resistor, which has been shown in this diagram. So these are the different types of inductors, and these are the different types of capacitors. So if we start with resistor, this is the symbol of resistor. So resistance or resistor. So usually we will call resistor as resistance. So, but resistance is not same as resistor. Resistor is an element, whereas resistance is the property of a resistor. So resistance means resistance means it is resisting the flow of current. If any conductor has resistance, that means that it is resisting the flow of current. It is not allowing the current to flow, so it opposes the flow of current. So when it is opposing the flow of current, when the resistor opposes the flow of current, what happens is some of the energy will be wasted in the form of heat. So we can call resistor as an energy dissipating element. So it dissipates energy in the form of heat. So here in this diagram you can see different types of resistors. Fixed resistor whose value is fixed, it won't change. Okay, and next you can see a variable resistor. You can vary the resistance value of this resistor. This is the actual resistors which you can see in the laboratories or in the circuit boards. If you open any device and if you see the circuit board inside the device, you can see these sort of resistors inside it. So this is the resistor. You can see a supply voltage of V volts has been given to this resistor. So because of this supply voltage, current of I amperes flows through this resistor. So when current of I amperes flows through this resistor, according to Ohm's law, the voltage that is given to the circuit will be always proportional to the current. So since the voltage is proportional to current, if you remove the proportionality, then it can be replaced by some proportionality constant. Here the proportionality constant is R. R is nothing but resistance. Now if you want to calculate the energy that has been dissipated by the resistor in the form of heat, actual formula for the energy dissipated by the resistor in the form of heat is I square into R into T. But power in the given circuit, in an electrical circuit, power is calculated in terms of voltage and current. So that power is, am I audible? Can anybody text me in the chat box? Am I audible? So power is equal to V into I. So if we know relation between voltage, resistance and current, so simply you can replace V by I into R. If you replace here this V by I into R, power will become equal to I square R. And if you replace, instead of replacing V with IR, you can replace I is equal to, from this equation, I is equal to V by R. So if I is equal to V by R, if you replace I here with V by R, you will get V square by R. So these are the three formulas to calculate the power in the given circuit. One is P is equal to V into I, other one is P is equal to I square R, other one is V square by R. So if we go to the inductor, so this is the symbol of an inductor. So inductor is formed by a finite length wire which has been twisted in the form of a coil. It has been listed in the form of a coil here. You can see this. You can see this is also a coil, and as I have already told you, see, this is also a coil. Now when current is given to this coil, what will happen is current will flow through this coil, and this a magnetic flux is induced within the coil because of the current flow in this coil. So these magnetic flux lines will be in the form of concentric circles. Those magnetic flux lines will be similar to the magnetic field that has been formed around a magnet. So similar, it means coil attains a magnetic property when current flows through the coil. So here what is happening, flux is induced, magnetic field is induced within the coil because of the current flow in the coil. So this current is causing the flux to induce here. So whatever flux that is induced, let us assume phi is the symbol of the flux that has been induced here, that will be proportional to the directly proportional to the current I. So that means that if the current is increasing, automatically the number of flux lines here will also increase. So this is the symbol of the inductor. Okay, the property of the inductor is inductance, similar to your resistor. For the resistor, the property of the resistor is resistance. Similarly, property of the inductor is inductance. So resistor dissipates energy in the form of heat. So an resistor is an energy dissipating element, but inductor is energy storage element. It stores energy in the form of electromagnetic field. So here, as when current flows through the coil, as flux is induced here, okay, this since flux is induced here, we can call this so since flux is there within the coil, so we can say that it is storing the energy in the form of electromagnetic field. So whatever flux that is induced, as I have already told you, if current increases, flux also increases. Therefore, in this case, flux induced is directly proportional to current. If you remove the proportionality, it can be replaced by some proportionality constant, that is L. Okay, so it can be replaced by some proportionality constant, that is L. So that L is nothing but inductance. So notation for inductance is L. So phi is equal to Li. So L is equal to phi by I, we can say, or we can say L is equal to d phi by d. You can say that d means differential. Okay, according to Mr. Faraday, so he has derived some laws. So according to his law, the voltage that is induced across a coil will be always proportional to rate of change of flux linkage. Rate of change of flux linkage means, so here when current is flowing through this coil, what is happening? Flux is induced within the coil. So some of the flux lines, they may travel in concentric circles. Some of the flux lines may travel through the air and they will just vanish away in the air. So when current is there, so of course this coil will also have some conductor. This coil is made by a conducting material. It will also have some resistance, but we are neglecting about it. We are considering it as an ideal coil. So here, whatever flux, okay, in there, if current varies, automatically flux is varying. So whatever voltage, that is voltage induced across this coil, that will be proportional to how flux is varying with respect to time within the coil. So that's it. Okay, how flux varies with respect to time within the coil, proportional to that voltage will be induced across the inductor. So V is equal to d phi by dt. What is phi? Phi equal to L into I. So replace phi by Li. So V equal to d by dt of Li. L is inductance, which is proportionality constant. So you can keep that proportionality constant aside, and you can write d by dt of I. V is equal to d by dt of I. So all of you write it down, whatever is visible here on this slide. So before that, you better draw this diagram. Okay, after drawing this diagram, I will give you a minute to draw this also. You draw this diagram also. No need to write this content, just draw the diagram, just draw two flux lines on this side and two flux lines on the other side. Now write down this content. No need to write the theory, just write down these equations what are visible here. Okay, I have given enough time now. So now here, as I said, since flux is directly proportional to current and since V is equal to d phi by dt, instead of phi I can write I. So I can say voltage is directly proportional to, instead of saying voltage is directly proportional to d phi by dt, I can say voltage is directly proportional to di by dt, because I is directly proportional to flux, or flux is directly proportional to current. So if voltage is directly proportional to d phi by dt or di by dt, you can replace proportionality by the inductance value. Okay, so L is nothing but the proportionality constant value. So V is equal to L into di by dt, I can say. Okay, so if you plot the characteristics of ideal inductor for the voltage with respect to the rate of change of current, then you will get a linear characteristics between V and di by dt. So this slope represents the linear characteristics. Now V is equal to L into di by dt. Therefore, I will, if I want I will be equal to 1 by L integral of V dt. Now, as I said, inductor is an energy storage element. It is storing energy in the form of electromagnetic field. So if I want to calculate the energy that is stored in the inductor, the energy is given by this formula. W is equal to half Li square. So now let us discuss about the capacitor. So capacitor will be consisting of two plates which are facing each other. So here you can see two parallel lines. They are nothing but two plates. I have an image here, I will show it to you. So in this image you can see there are two plates which are facing each other. Let's expand it, let me see. Yeah. So you can see two plates which are facing each other, and voltage source is connected to these two plates. So when supply is given, here you can see this is the positive terminal of the source, this is the negative terminal of the source. So this plate, it has a charge has been accumulated on this plate, which is positive. Charge has been accumulated on this plate, that is negative. So one plate is positively charged, another plate is negatively charged. Okay, so there is an air gap between these two plates. So you can place a dielectric material within the plates, which you people already know, you might have already learned. So here the property of the capacitor is capacitance, similar to your resistor. Property of resistor is resistance, property of inductor is inductance, property of capacitor is capacitance. So because of this capacitance property, it stores the energy in the form of electrostatic field. So this is the electric field that has been developed within the plates because of the charge that has been accumulated on these plates. So capacitor will have two plates. So one plate will be charged. If one plate is charged positive, another plate will be charged negative, and both are of opposite polarity. So they will be storing an energy in the form of electrostatic field. So this is the symbol of capacitor. Two parallel lines facing each other is the symbol of capacitor. So capacitor property is capacitance, stores energy in the form of electrostatic field. And there are different types of capacitors. You can see here, this capacitor is known as fixed capacitor. So if you just one of the plate, instead of drawing it with a straight line, if you just draw it like a curvy line, then it is known as polarized capacitor. And if you draw two parallel lines, and if you put an arrow mark on it, that is known as variable capacitor. This is the symbol of capacitor. Okay, this is the actual capacitor which you can see in your toys or any electronic devices, you can see it. So here the current that is flowing, okay, for it, let us go here. Okay, so this is it. So you can see a capacitor here. So we are giving a supply voltage of V volts, and because of the supply voltage, what is happening, current of I amperes is flowing into the capacitors. So as I already told you, these are two plates on which charge is accumulated. So the charge that is accumulated on the plates will be directly proportional to the voltage that is induced. Voltage that is applied, sorry, not induced, it is whatever voltage that is applied to the capacitor. Okay, the charge that is accumulated on the plates will be proportional to the voltage. So you can write like this: the charge Q, if Q is the charge, that will be always proportional to the whatever voltage that is applied across the capacitor. That means that if the supply voltage increases, then the charge that has been accumulated on the plates will also increase. If the supply voltage decreases, the charge accumulated on the plates will decrease. So you can remove the proportionality with the proportionality constant, that is Q. The proportionality constant is C. So you will get Q is equal to C into V. So C is equal to Q by V. So you people write down capacitor and draw this diagram. I hope you have drawn this. Now write down these terms. Charge proportional to the voltage. If you remove the proportionality, it has been replaced by capacitance C, and C is equal to Q by V. Now, so we already know a basic definition of current. Current is rate of flow of charged particles in a conducting material. So since current is rate of flow of charged particles in a conducting material, so current is given by I equal to dq by dt. And we all just now we have seen that q is equal to C into V. Therefore replace q by CV. So if you replace q by CV in the above equation, it will become I equal to d by dt of CV. So where C is a proportionality constant, you can bring out this C and write it aside. So you will get I equal to C into d by dt of V. So since I is equal to C into d by dt of V, if you want voltage, then V will be equal to 1 by C integral of I dt. Just note it down. So if you want to know the characteristics of voltage with respect to charge, then they both will also have linear characteristics. You can see a slope here which shows that voltage and charge are having linear characteristics. Okay. So now, as I said, capacitor stores energy in the form of electrostatic field. So if you want to calculate that energy which has been stored by the capacitor, its formula is half W equal to half CV square. So this is it. So the energy stored by the capacitor is half CV square. So write it down. So I have summarized whatever we have discussed. This is the resistor, this is the inductor, this is the capacitor, this is the symbol of resistor, symbol of inductor, symbol of capacitor. So current in the resistor is given by I equal to V by R. Voltage in the resistor is given by V equal to I into R. And current in the inductor is given by I equal to 1 by L integral of V dt. And voltage in the inductor is given by L into di by dt. And in the capacitor, the current in the capacitor is given by I equal to C into dV by dt, and voltage in the capacitor is given by 1 by C integral of I dt. So you can write down all this at one place in a tabular column, so it will be easy for you to remember. while solving the problems. So if you can recall by looking at this table, if you are able to draw this table. Okay, then let's get into the next topic, that is sources. So sources is not mentioned in the syllabus, but we must have basic knowledge of what are all the different types of sources, so that it will be helpful to learn the remaining topics. So that's why I'm going to briefly discuss about these sources. So as I'm explaining, you can parallelly note it down so that our time will be saved. So source is a device which can convert mechanical, chemical, thermal or any form of energy into electrical energy. Since I'm discussing about electrical circuits, so that's why I'm talking about converting some form of energy into electrical energy. So I have an image here, I will show it to you. Okay, so you can see in this image, this is actually how electrical energy is generated in the generating stations. So this is a basic model of thermal power plant. So you can see here it is written coal here. So from here coal is poured, okay, and it is burned here. So and when coal burns, what is happening here is this water, blue color arrow marks, if you observe carefully, this water which is flowing through these pipes, this water is getting heated up and it is converted into steam. These red lines are nothing but red color arrow marks are nothing but steam. So that steam enters into this chamber where a turbine is there. Okay, so because of this steam, what will happen is this turbine will rotate. When turbine rotates, this rod which is attached here, okay, this rod will also rotate when the turbine rotates. When the rod rotates, the generator armature will rotate, and hence electrical energy is generated. Okay, I'm just briefly discussing about this here. This is not our actual content, so I'm just briefly discussing here. So what is happening here? Here chemical energy is converted into thermal energy, then later it is converted into mechanical energy. Mechanical energy is converted into electrical energy. So the working principle of generator or function of generator is it converts mechanical energy into electrical energy. Okay, so just I am telling you the function, not the working principle of generator. Its function is to convert mechanical energy into electrical energy. So the electrical energy is given to the transmission line, from there it is given to the different load sectors. So energies are converted from one form to another form. At last we are getting the electrical energy here. Okay, so source is what? Source is a device which converts mechanical, chemical, thermal or some form of energy into electrical energy. So you can mainly categorize the sources into two types: voltage source and current source. Okay, you can broadly categorize the sources just simply into voltage source and current source. Just write down the title and write down these two: voltage source and current source. Now let us see what is the voltage source. Okay, so voltage source, you can see here, I have a bigger image in this slide. So voltage source is a two terminal device. You can see terminal A and terminal B. Okay, so these are the ends actually. A and B are the ends. It has two, one positive electrode and one negative electrode. Okay, and positive, you can call these electrodes as terminals also. Usually the ends are called terminals, but since we are using here, this is a DC voltage source actually, so you can even call the electrodes as terminal. This is the positive terminal, this is the negative terminal. Okay, positive terminal it will be usually larger than the negative terminal. Okay, so you can even represent the voltage source with a circle, and you can mention V besides to it. And here also you can mention with two lines. One is larger line, which is positive terminal, and a smaller line which is negative terminal, and you can write V besides to it. It shows that it is the voltage source. If you write V here, that means it is the voltage source. Okay, so it provides the required voltage for the circuit elements. The purpose of the voltage source is whatever voltage that the circuit requires, to that circuit it provides the required constant and specified voltage will be given by this voltage source. Okay, these two are the symbols of voltage sources. Examples for the voltage sources are batteries and alternators. Alternator is nothing but a generator. Just now I have shown you one image, that was the just image form. This is the photo of the generator, alternator. AC generator is known as alternator. So this is the alternator. These are the batteries which we can get. We all are familiar with these batteries. They are also the sources. Okay, so I hope you have understood. So all of you just write down the title and write down these three lines, and even write down this, draw these two symbols. So let us discuss about the current source. So current source, it gives the specified amount of current that is required by the circuit elements. So current source is represented by a circle with an arrow mark inside it. So this red color line is nothing but the arrow mark. So whatever current that is required by the circuit elements, that can be that is provided by this current source. Current source can be ideal or practical current source. So since it is not there in the syllabus, I am not going to discuss about it. Okay, so you just write down this current source heading and write down this content in your notes.